Okay, we are finally about to be done with this whole semester-long project. I've been swearing I'm going to do another video about the percentages and the graphs. I already have a previously recorded one set up to open next week, but I am making a brand new one right now that I'm going to post. I'm going to post in the announcements, and I will make sure to post it in this week and next week so you have a brand new one. In it, I'm going to remind you how to do graphs. I'm going to explain the percentages, how to calculate them, why it's important, and remind you what the main purpose of this entire project is. So here we go. I am going to do sharing the whole friggin' desktop so you can see everything. I have a lot of crap. Don't judge me. Okay, first and foremost, I am going to show you graphs. When I originally showed this on the Zoom session where, I don't know, a couple people showed up and then I posted, what I did was I just did the world. So world deaths, rate of change. I've already given you an Excel sheet that does the entire rate of change. So you've been entering your data on those top two. The bottom two are calculating for you. That's the rate of change. That's what you need. Now, I went ahead and I put my dates here. So this is what I am going to be using as this area right here that's highlighted. There's nothing under January 1st because I don't have a rate of change there. So it's going to start with January 7th. Your stuff is obviously going to go way past March 25th. This is just what I used previously for this example, so I'm using it again. There are a couple of ways to do these graphs. This I find the easiest, even if you have to take a moment to set all of these up. Go ahead and grab this and highlight the dates and the numbers. Then you're going to go to Insert, and then you see all the graphs here. I like this one, the line graph, and I like to have my data points. And it puts it here. Now, notice it's doing something weird. I remember I had this problem before, and it's because it decided what dates these were. So you might have to fix them. So this should be 2022. And then this one should also be 2022. Don't ask me why Excel decided to change these things, but it did. So if your graph is not matching what it should, that is what you need to do, is immediately click up here in the toolbar and then check. So see, now we have all the 2022s. Now this makes sense. So this is our change, our rate of change. Now the next thing you're going to do, click here where it says chart title, and I would put here world rate of change. So that lets, whoa, look at that. I forgot the D for world. World rate of change, and then maybe do a dash. That looks a little nicer. That's really all you have to do. So this is the number of cases in the world. Notice it went way up right around here, and then it came down, and then it started to go up again. If we put more in here, we would then be able to watch. Part of what your task is, why I had you start all the way from the beginning of the year, is I want you to be able to see the ebbs and flows over the entire year. It's going to be very telling. When you are looking at trying to decide what is actually happening, and that dog is driving me crazy, when you're doing the critical thinking aspect of this, I want you to actually look at this and think about the dates. Why do you think it might have been climbing and then coming down? What do you think may have happened here and then all of a sudden start to come up? Well, very good rationale. If we started using our numbers the 1st of January, this is a rate of change 1 week into January. That means right after the holidays, there were a lot of parties. It will then continue to climb. Why did it go all the way up through February high, well, it's normally about a 2-week off. It would be nice if that would stop. But anyway, it's going to be about 2 weeks off. So this peak time right here is actually from towards the end of January. This is the world. You have to look at all the holidays, all the things that are happening around the world. When you're looking at just the US, it makes it easier because we have our own very specific holidays, but different countries have different holidays. But it's that kind of thing. If I was using the US, then it would, be easier. But like I said, I was just using stuff that I already had together. Now, I guess let's set this up for the deaths. So let's see, we are going to move this graph out of the way. Actually, let's see, we're going to move it way down here to totally get it out of the way. Then I am going to do these dates, copy, and paste. And then I am going to do the rate of change. So equals this minus this, enter. Oh, I already had them. Never mind. So I just realized that. Delete. So which one did I just do? Oh, this is the rate of change of the deaths. Okay, so let me adjust that. World deaths, rate of change. So now let's do one of just the actual cases. So we're going to highlight these. And then remember, insert, pick your graph. And then, of course, we're going to have to fix the dates, but I'm going to go ahead and do this first and say world cases rate of change. So I already have my thing done. And now I'm going to have to fix all of these. I wish I knew why it decides to make it a different year. I'm sure there's a very obvious reason. I just do not know said reason. There we go. Now, why I wanted to show you world cases and world deaths, and yes, it's bothering me that I didn't capitalize that. There we go. Okay. The deaths from COVID tend to be 1 or 2 weeks behind the cases. So here, notice it spikes massively right after, like 2 weeks after the New Year's. It's up here. And then it gets higher for some reason, and then it starts to come down. So it is starting to come down by February 4th, but notice here, February 4th is where it's still plateauing. It doesn't start coming down until 2 weeks later. Then here where the deaths spike, March 25th, March 11th is when it starts to go up. And so you are supposed to be comparing your cases, your positive cases, rate of change. This will be matching holidays, vacations, spring break, events, whether it's concerts or we just had elections and everything. A lot of times you will find spikes in certain areas for some of the big, I can't think of the word, the big, I don't know, things. Why can't I think of the word? Oh, it's driving me nuts. It's where a bunch of people get together to watch the politician, bleh. So anyway, you'll have a lot of times, a lot of people run to those, and that will cause this. Then the deaths happen a couple of weeks after. And so you're basically looking at this and seeing if they match. That's pretty much it. So hopefully that helps you with what you're looking for here and doing the rate of change. Now, I am going to talk about the percentage aspect. For this, I am going to use Argentina. So I'm going to say Argentina. It's because I don't feel like typing. So I'm going to use Argentina. I am going to say positive and then deaths and population. Okay, so here's what we're going to do. I am going to go here, which is the website I gave you before. And this is where I get a lot of the information. You will notice they have the total cases, the total deaths, they have population. So I am going to go to Argentina. I want to go to Argentina. Okay, right here. This is my Argentina. So population is right here. Copy. So this is my population for Argentina. There we go. And then I am going to do my positives. And you don't have to put it in this order. I am just doing this in order to make it easy to show you. And then here are the deaths. Okay. All right. So to do your percentages, what we are looking for is percent of population with positive COVID. So this will be what percent of the population has officially gotten tested positive for COVID. Now, this is not super accurate because not everybody went and got tested and had it, recorded. Some people show no symptoms, so they have no reason to test. Once we started having the test at home, a lot of people tested at home, they don't report it. Some people get sick, don't bother testing because their attitude is, who cares? It's not like there's anything I can do. So it is actually very underreported, even though a lot of people like to say that it's not accurate and that it's too much. It's actually underreported. So what you're going to do is you're going to divide the number of cases by the population. So if you want Excel to do it, you would just do equal sign, then I open parentheses, positive divided by population, close parentheses, times 100. I'm doing that because that will give me literally the percentage. This means 21% of the population. So 21% of Argentina have tested positive for COVID. There you go. Now, if I want to know how many of the people who tested positive died in Argentina, then I would do equals, open parentheses, deaths divided by the positive cases, close parentheses, times 100. So this means that 1.3% of those who tested positive for COVID in Argentina died. There you go. So that's literally how you do this. Now, to give you an example from one of the US things, I am just going to pick one at random. Dun, dun, dun. So same thing here. We've got our population. We've got that. So let's pick, I'm going to pick Kansas. So Kansas, we have, there we go. This is the number of cases. So I'm going to say here, Kansas. Cases. Whoops. Hit the wrong hotkey. So we will just go back to that. That's their population. This is how many have died. There we go. And then the population of Kansas. I have no idea why I picked Kansas. I have no idea what to expect from this because, again, no idea. So if I want to know how many of the population got tested and came back positive, it would be equals, open parentheses, this divided by total, the population, and then times 100. So this would mean 30.6% tested positive. Now, for how many died, equals, open, and then I do deaths divided by number of cases, close parentheses, times 100. So this one means 1.08%. So that's how many would have died. This is a way that you can take a large area and a small area and compare them. Because if you look, the population of Argentina is over 46 million. So you would expect them to have a lot more positive cases and a lot more deaths. Not even 3 million population for Kansas. So obviously you would expect these numbers to be lower. If you look at 9.7, that would work, but 9,720,232 positive cases, you'd be like, oh my gosh, Argentina had so many more. And you look at only 892,000, but look at the difference in percentage. 21% of Argentina tested positive. 30% tested positive in the state of Kansas. That means it was a higher infection rate in Kansas than it is in Argentina. Then you look at their death rate and you discover that 1.3% died in Argentina, 1.08% died in Kansas. That means it's a slightly higher rate of death in Argentina, which can make sense due to, medical facilities and stuff. This is a very important concept because you're going to be comparing places like California. Let's look at the difference in population here. You're going to be looking at places like, and I'm doing this to make it easier. You're going to be looking at a place like California, where you see over 11 million cases, but their population is 39 million. And then you might compare it to, well, we'll just do Alabama. You look at California with over 11 million cases, and then you look at Alabama with 1.5 million cases. California clearly is going to look worse, but look at their populations, 39 million, well, 39.5 million versus just under 5 million. That's a big difference. So let's do a quick comparison for these. We're going to do Alabama and California so we can compare them. So I am going to put Alabama here, and I'm going to put California here. Okay. We're going to do positives, deaths, and populations. So positive case for Alabama. And I'm doing this, one, to give you a couple of times so you can see exactly how to do it. And two, so you can see why it's important to compare these two. This is the only way you're going to be able to properly analyze what these numbers mean, is to do this kind of thing. Okay. Da-dum, da-dum, dum, dum. At least we're almost done. And sorry it took so long to make this video. It's been crazy, crazy, crazy times, which I'm sure it has been for you guys too. I can't believe our term is so much almost over, and I just hit the wrong button. Darn it. I accidentally hit cut, and so I cut nothing. There we go. And then population. So we've got the population of Alabama. And then the population of California. California has a lot of people. Okay, there we go. So we're going to do the same thing. We're going to do, okay, this is going to be positive cases. These are deaths. Whoops. Actually, I should just say positive deaths. Positive deaths. There we go. Okay. Number of positive cases. Again, we are going to take the number of positive cases divided by the population. And then this one will be the number of deaths divided by the number of cases times 100. Equals open. This one divided by this one. And this one will be this divided by this. Okay, why is this telling me there's something? So that was C divided by B. Yeah, that's right. Okay, so this means 31.3% positive. And actually, I'm going to put all these where it centers because I don't like how that looks. There we go. This one is 1.3%. This is 28.8%. And this is, wow, that's pretty impressive, 0.85%. So according to this, the rate of cases in Alabama is worse than Argentina, Kansas, and California. California has fewer cases than Kansas, but more than Argentina. Then if we look at the death rate, 1.3% is the death rate for Alabama, which is the same for Argentina, and is a lot more than California. So California had fewer, percentage-wise, fewer cases positive, and their death rate was a lot less. So it's not even 1%. That means California was doing something right to help keep the infection down some, and they have 100% been doing something right to keep the death rate down. That's very important. So this is what you're looking at. So if you're really taking this seriously, what you need to be doing, do this for every one of your states and the US so you can compare, so you know you're comparing apples to apples, so to speak. You can't go by these numbers to compare. You have to go by percentages. That is the only way you can actually properly compare these. Last thing I wanted to show you. I am going to open, that's my schoolwork. going to open a document, and I'm going to show you this as well. So you're going to do things like the following graph shows blah, 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 blah. Tell me what the graph is. And then check this out. Click here, right click, copy, go here, paste. Click outside the graph, enter, and then, whoops, click here, copy, and then to the Word document, paste. This is how you put all of your stuff in there. This is literally how you turn it in, because when you turn this in, you can only attach one file, and I have to see all of your graphs. I need to understand your graphs. Please don't try to be all fancy and funky and do bar graphs and stuff that doesn't actually show me anything. The only way a bar graph works is if you are comparing like these percentages. So if you wanted to compare state by state and do bar graphs to compare them, that would work. The graphs I'm looking for are these, but they need to be complete graphs. So it's going to have to show me everything. Yeah, I think that's pretty much it. So that was a quick recap on how to do the graphs, showing you percentages, populations, what I mean by it, and how to actually use this for your critical thinking aspect on this project, because a huge portion of what you're being graded on here is going to be whether or not you actually learned something. And that's kind of a big thing. So I guess that's it. Good luck.